So now we can look at the perspective projection, what it actually does here in a picture. So here we have our viewing frustum set up along the negative z-axis. We know that the near plane stays at the near plane, the far plane stays at the far plane, and in between we get this 1/z relationship. So things move around, but when we look at the outside of this frustum, all what's going to happen is that the frustum is basically changed to a rectangular area. In pictures, it will look something like this. So essentially that far plane get reduced in size to the same size as the near plane. So things on the far plane, they get scaled down with a ratio of near over far, and things on the near plane, they stay the same. So what we have to look at, therefore, to understand how do we get from our frustum into the canonical viewing volume, or also called normalized device coordinates, is to look at how this rectangular area gets into that canonical viewing volume. Now, the canonical viewing volume is a volume centered at the origin with a side length of 2. And we have this rectangular area somewhere along the negative z-axis of the camera, either because we're doing orthographic projection to start with, or we start with frustum, but we apply the perspective projection first. And after the perspective projection, the size of objects is adjusted. However, we still have that z dimension, so we're still dealing with a volume in 3D. And in particular, it's a rectangular volume as well. Taking a rectangular area along the negative z-axis and turning this into a cube at the origin is relatively simple. All we have to do a translation to center it at the origin, and we have to do a scaling to make sure that the sides are all the same length, and in particular they are of length 2. That's the operation to get from the rectangular area to the canonical viewing volume. I have a scaling matrix, a translation matrix, and then they're multiplied together because we need to do both things. What is the scaling? Beforehand, we have a width of our viewing area between right and left plane, and afterwards this distance should be 2. So I just form these ratios here. Top minus bottom should be 2 afterwards. Near minus far should also be 2. So it's the same here. So this is the scaling we need to scale that rectangular area into a cube with side lengths of 2. And then we have to translate it to the origin. Again, that's fairly straightforward. We basically just take the middle of that volume and see how far that volume is away from the origin, and hence use this as a translation vector to get that volume centered on the origin. So that's why we have the minus here. And when you look at the distances, we're going right plus left divided by 2. So this is the center of the, in the right-left direction of the rectangular area. And then we have top plus bottom divided by 2. That's the center in the height. And then we have near plus far divided by 2. Again, that's the center in the z dimension. So let's look at what OpenGL and WebGL actually does with Ortho. So this is the matrix from the documentation, and it looks all the same except for the minus signs down here. So here I'm using to write these numbers here on the negative z-axis as absolute values. So that changes things a little bit, but the major thing, since all our z coordinates in front of the camera are negative, is this minus sign here and the minus sign here. And what this will do, if you can try it out, if you put in, for example, a value on the near plane, that means that the mapping is such that n, a point on the near plane, maps to -1, and a point on the far plane maps to 1. So that's why I'm saying up here, the image plane afterwards is a z equals -1. So when we look at perspective projection, because as we said, the perspective matrix really takes this volume, this viewing volume, this frustum, and turns it into a rectangular area, which is then just as the same situation as orthographic projection, which then the orthographic projection takes that volume, that rectangular volume, and scales it and translates it so that it's a cube at the origin. So when we look at the perspective matrix and the orthographic matrix, which we just put together, the overall effect of perspective projection is, as you can see here, refers to apply the perspective projection on 2 points and then the orthographic to get the overall effect. And again, if we're looking at the documentation, we can also see directly what frustum does and what it sets the matrix to. So this is from the documentation. Again, you will notice down here -1, and this -1 is there to make sure that again the image plane shows up at z equals -1 afterwards in this cube at the origin and not at +1.